All right, let's dive in. Today, we're going to unpack this single piece of tech that basically lit the fuse on the whole modern AI revolution. This is the story of how machines finally, truly learn to understand what we're saying. Seriously, have you ever stopped to think about that? When you type something into an AI like ChatGPT, how does it really get what you mean? You know, the nuance, the context, the actual meaning behind your words? It feels like magic, right? Well, it's not magic. It's an absolutely revolutionary piece of technology, and that's exactly what we're breaking down today. So, a few years back, the entire world of AI had this seismic shift. It was one of those moments that changed literally everything, and it all comes down to one single groundbreaking idea, an idea that built the foundation for all the AI tools we're using pretty much every single day. And get this, it was all because of a single research paper. I'm not kidding. Back in 2017, some researchers at Google dropped this paper introducing a brand new architecture they called the transformer. Now, this is the engine that's humming away inside models like ChatGPT and Google's BERT. It's the reason AI suddenly got so good, so incredibly fast. Okay, but to really appreciate why the transformer was such a game changer, we gotta rewind the clock. We need to look at the world of AI before 2017. And honestly, the biggest problem they were all struggling with, it boils down to just one word: memory. So the go-to models back then were these things called recurrent neural networks, or RNNs for short. And they had a huge fundamental flaw. They had to read information one word at a time, sequentially. Imagine trying to read a whole novel by looking at it through a tiny little peephole. By the time you get to the end of a sentence, you've completely forgotten what was at the beginning. That was the problem. And I mean, the difference is just night and day. The old way was painfully slow. And because it was chugging along word by word, it just couldn't connect the dots in long sentences. You know, like connecting the subject at the start of a paragraph with a pronoun way down at the end. It just lost the plot. The context was gone. But the new way, the transformer, it sees the whole sentence at the same time. And this wasn't just about being faster. This was the real breakthrough. This parallel processing meant you could train these models on just insane amounts of data all at once. That's what made AI suddenly become so powerful, so fast. So how did they crack it? How did these solve this massive memory and context problem? Well, it was with this brilliantly simple, super powerful idea that also has a pretty awesome name. Yeah, that's it. That was the actual title of that game-changing paper. Attention is all you need. It sounds kind of bold, right? But it absolutely nails the core idea. What these researchers were saying was, hey, to understand language, maybe an AI doesn't need all this complicated one word at a time stuff. Maybe it just needs a way to pay attention. And the mechanism they built to do this is called self-attention. Look, think about how you read. You don't just process words one by one. Your brain is constantly making connections. If I say, the robot picked up the ball because it was heavy, your brain instantly knows it is the ball, not the robot. Self-attention is what finally gave AI that same superpower. So how does that even work under the hood? Conceptually, it's kind of like a three-step process. First, the model looks at one word. Then it asks a simple question for every other word in the sentence. How important are you to the word I'm looking at? It gives each one a relevant score. And finally, it uses all those scores to create a brand new, super context-rich meaning for that original word. And the crazy part? It does this for every single word at the exact same time. Okay, so this attention thing is obviously the secret sauce. But how do you actually build a machine around it? Well, that brings us to the actual nuts and bolts of the transformer architecture. Probably the easiest way to picture a transformer is like a highly skilled two-person translator team. First, you've got the encoder. Think of them as the reader. Their only job is to understand. Then you've got the decoder, the writer. Their job is to take that understanding and craft a response. So the encoder's whole mission is just to understand. It takes in your sentence, it uses that self-attention magic we just talked about, and it creates this incredibly rich mathematical representation of what you said. It's almost like it's turning your sentence into a super detailed set of coordinates on a map, a digital map of meaning, where every word's location is defined by its relationship to all the others. Right, so then the decoder gets that digital map. Its job is to write. It looks at the map from the encoder and starts building the output one word at a time. But here's the cool part. As it's writing, it's also paying attention to the words it's already written. That's how it makes sure the final sentence is coherent and actually makes sense. So this whole encoder-decoder setup with self-attention as its engine, this isn't just some abstract idea on a whiteboard. Nope. It is the direct ancestor of pretty much every famous AI model you've ever heard of.
Seriously, think about it. Every time you use Google or a translation app or, a chatbot, you are directly interacting with the legacy of this one idea. This architecture is the engine that's powering the entire AI boom we're living through right now.
And what's just mind-blowing is how fast this all happened. The paper comes out in 2017. 1 year later, 2018, Google's BERT is already using the encoder part to completely revolutionize search. Then, just 2 years after that, 2020, OpenAI drops GPT-3, which is based on the decoder, and it just takes the world by storm. The speed of this innovation was just unreal. Look, if there's only one thing you remember from all of this, make it this. The real magic of the transformer isn't that it's good at predicting the next word. It's that it gave machines, for the first time, a real way to understand context. All those subtle little connections between words that create actual meaning. That's the whole game. So yeah, this one piece of tech completely reshaped our world, all because we taught machines how to pay attention to our words. Which, leaves us with a pretty big question. Now that they've got a handle on language, what should we teach them to pay attention to next? Complex patterns? Ideas? Maybe even emotions? It's something to think about for sure.